Hello everyone. So today we are going to discuss about electromagnetic induction. Before that, let me introduce myself. So my name is Namhang Limbu. Roll number is 19NS0067. Fourth semester, Physics Department, and college is Namchi Government College, Kamrang, South Sikkim. So today our topic is electromagnetic induction. In this topic we are going to cover introduction part, experiment, history, applications, and advantage and disadvantage. So let's begin. So what is electromagnetic induction? Electromagnetic induction is simply the phenomenon phenomenon of production of induced EMF or induced current due to change of magnetic flux. Electromagnetic induction is simply the phenomenon of production of induced EMF or induced current due to change of magnetic flux. So in this topic we are going to produce a current with the help of magnetic flux. Let's see how it's work. So now let's study in brief of history of electromagnetic induction. Okay, in the early part of 19th century, the experiment of Ampere and others established that moving charge produce a magnetic field. That means moving current produce a magnetic field. The converse effect is also true. Yes, that is moving magnet can produce electric current. Moving magnet can produce electric current. In 1831, Michael Faraday in England and almost simultaneously Joseph Henry in the USA discovered that current are produced in a loop of wire if a magnet is suddenly moved towards the loop or away from the loop such that the magnetic flux across the loop changes. The current in the loop lasts as long as flux is changing. The phenomenon is called electromagnetic induction, which means inducing electricity by magnet. Which electromagnetic induction means inducing electricity by magnetism or a magnet. In 1831, Michael Faraday discovered electromagnetic induction. So we'll see who is Michael Faraday in brief. Okay, Michael Faraday, he was from England, 1791 to 1867. Faraday made numerous contributions to science: the discovery of electromagnetic induction, the law of electrolysis, benzene, and the fact that the plane of polarization is rotated in an electric field. He also credited with the invention of electric motor, electric generator, and transformer. He is widely regarded as the greatest experiment scientist of the 19th century. In this topic, our main aim is to create a current with the help of magnetism. So now let's discuss the Faraday's experiment, how induced current is generated with the help of magnetic field. So this is first experiment. Okay, so in this first experiment उसले के लेख्छ एउटा soft soft iron coil. Soft iron coil. One end of soft iron coil is wound by a wire which is connected with switch and battery. Another end of coil is connected with galvanometer. Galvanometer is the instrument which detect current. Okay, which detect current. So let's give this as primary and this is secondary coil. Okay, so when switch is closed, current start flowing in this coil, and with so due to this current magnetic field lines produce हुन्छ. Magnetic field lines produce are linked with this coil and reaches this another end. पुग्छ किन this coil is made of soft iron coil which is ferromagnetic material which accepts large amount of magnetic field, but galvanometer does not show any deflection. That means हाम्रो induce current छैन, induce current create भएको छैन or generate भएको छैन. Magnetic field lines त छ but हाम्रोमा current produced भएको छैन because galvanometer does not show any deflection. So उसले फेराडेले के गर्नु थाल्यो, स्विच अन ल अफ गर्नु थाल्यो. स्विच अन ल अफ गर्नु थाल्यो त्यति बेला के उसले नोटिस गर्यो ग्याल्भनोमिटरले डिफ्लेक्सन दियो. ग्याल्भनोमिटरले डिफ्लेक्सन दियो मतलब करेन्ट छ. स्विच अन ल अफ गर्दा चाहिँ के हुँदैछ भन्दा चाहिँ एकखेप करेन्ट क्रिएट हुँदैछ, एकखेप ड्रप हुँदैछ, फेरि क्रिएट हुँदैछ, फेरि ड्रप हुँदैछ भने सिमिलर वे म्याग्नेटिक फिल्ड पनि बनिँदैछ. एकखेप फेरि ड्रप हुँदैछ, फेरि बनिँदैछ, फेरि ड्रप हुँदैछ. त्यति बेला induced current create भएर galvanometerले show गर्दैछ. So that means change in magnetic field is responsible for generation of induced current. किनभने हाम्रोमा अघि नै अलरेडी स्विच अन गर्दा नै हाम्रोमा म्याग्नेटिक फिल्ड त थियो तर ग्याल्भनोमिटरले केही डिफ्लेक्सन देखाएको थिएन. तर हामीले जब स्विच अन अफ गर्न थाल्यो त्यति बेला डिफ्लेक्सन देखायो. That means change in magnetic field is responsible for generation of induced current. Okay, now यहाँको इलेक्ट्रिक फिल्ड लाइन्स यहाँ पुग्छ, यहाँ बेसी हुन सक्छ, यहाँ बेसी हुन सक्छ, यहाँ बेसी हुन सक्छ, यहाँ कम्ती हुन सक्छ. सो इट्स डिपेन्ड अन एरिया अफ द सर्फेस. सो म्याग्नेटिक फिल्ड इन्टु सर्फेस गऱ्यो भने हामीले के पाउँछौँ, म्याग्नेटिक फ्लक्स. Magnetic flux represented by phi is equals to magnetic field times of area. That means let's change the statement. Change in magnetic flux is responsible for generation of induced EMF or induced AMF. Change in magnetic flux is responsible for induced generation of induced current. Okay, so यो एक्सपेरिमेन्टमा फेराडेले के युज गरेको थियो, ब्याट्री. सो हामीले क्वेसन उठाउन सक्छ यसमा, किनभने ब्याट्रीबाट करेन्ट पास भयो यसमा, यहाँ पास भएर यता पास भएर हामीले ग्याल्भनोमिटर सिम्पली डिफ्लेक्सन देखाउन भन्न सक्छौँ हामीले. त्यसो भए सेकेन्ड एक्सपेरिमेन्ट इज मस्ट इन्ट्रेस्टिङ, किनभने फेराडेले सेकेन्ड एक्सपेरिमेन्टमा विदाउट ब्याट्री गरेको छ. Let's discuss Faraday's experiment to induce EMF or induce current with a stationary coil and moving magnet. Means magnet in motion and coil is in rest. Coil is in rest, magnet in motion. The coil is simply connected only with galvanometer. Okay. So now when the north pole of bar magnet moves towards the coil, galvanometer shows deflection. That means current is produced in a coil. So in second when the north pole of bar magnet is moving away from the coil, again the galvanometer shows deflection. Okay, so in third case, when magnet in rest, already our coil is in rest, magnet is also in rest. In this case, galvanometer does not show any deflection. From experiment 1 and 2, we are clear that change in magnetic flux is responsible for induced generation of induced current. Now, let's discuss the law of electromagnetic induction. Basically, there are two laws, Faraday's laws and Lenz's law. Faraday's law, which gives magnitude, magnitude of induced EMF or induced current, and then Lenz's law, which gives direction of induced EMF or induced current. So Faraday's law ले के दिन्छ हामीलाई magnitude of induced EMF, Lenz's law ले direction of induced EMF. First Faraday's law. Faraday's law मा दुईटा law छ. So first one is whenever the magnetic flux link with a closed circuit changes, an EMF is induced in it, which lasts as long as the change in flux is taking place. Okay, we know that. In second law, the magnitude of induced EMF is equal to rate of change of magnetic flux links with a closed circuit. That means the magnitude of induced EMF, is equals to rate of change of magnetic flux. That means d phi by dt. Faraday's law ले के दिन्छ magnitude of induced EMF. That means magnitude of induced EMF is equals to rate of change of magnetic flux d phi by dt. Now Lenz's law ले के दिन्छ direction of induced current. So Lenz's law states that the direction of induced current is such that it opposes the cause of produce it. That means के हुन्छ भने यसमा अलिकति हामी हेरौं यसको cause. The law states that direction of induced current is such that it opposes the cause which produce it. Okay, so यसमा मैले एउटा कोअर्डिनेट बनाएको छु x y and z, अन्त एउटा कोइल लेख्छु छु, एउटा म्याग्नेट. So when magnet moves towards coil, यो कोइल ले यस्तो खालके पोल प्रड्युस गर्छ which repel this pole. त्यसो भने यहाँ यो कोइल ले के पोल प्रड्युस गर्छ, नर्थ पोल, which repel the magnet. And then when this magnet moves away from this coil, in this case this coil forms a pole which attract the magnet. That means it produced south pole to attract magnet. This law reflect the conservation of energy. So when the magnet moves towards this coil, the current will be anti-clockwise. But when the magnet is moved away from the coil, the direction of induced current will be clockwise. When magnet moves towards coil, the direction of induced current will be anti-clock, and when the magnet moves away from the coil, the direction of induced current will be clockwise. Application of electromagnetic induction. There are many applications of electromagnetic induction. So I have only written 3: electric motors, AC generator, transformer. AC generator is a device which convert mechanical energy into electrical energy. Transformer is a device which transfer electrical energy into one transformer to another circuit, one circuit to another circuit. So these are the applications, and let's see the merits and dismerits of electromagnetic induction. Merits of electromagnetic induction. Advantage of electromagnetic induction is AC or DC electrical power can be generated using electromagnetic energy source. It eliminates the need of an external electrical source to generate electrical power. These two are advantages or merits of electromagnetic induction, and demerits of electromagnetic inductions is the electromagnetic field generated to produce electricity can be dangerous under certain circumstances.